Okay, 8-1 day 2, third hour officially, well, if this works, which is a 50-50 chance with this computer. All right. All right, so this says number 3 because you remember the notes from yesterday? There were 6 different ways to pictorialize into what we're going to do. I'm sure there's way more than that, but this is the third way, a simple basic bar graph. This is such grade school stuff, so just appreciate the easiness of what we're going to do next, being able to read. We'll construct, but then also reading from a bar graph, which is really grade school stuff. Then the last thing, the only hard part, it's the same thing as last semester. The hardest part was having the vocab words with the method to be used and then doing the right thing at that point. All the things that need to be done are pretty mathematically simple, but when you jump through, that's what school is anyway. Go to English, you go to history, you go to math. Every teacher's sprouting out new words at you that you got to memorize, and I guess that's the only thing that could be a challenge today. All right, with all that being said, we had a basic bar graph. I don't know if this is a hard and fast rule, but for at least this book, a basic bar graph, the bars don't touch. They're independent of each other, don't touch each other. And then we could start off by writing this, and we're going to bar graph it out, which you can see the beginning of my graph down here. So get a survey. Remember, that was one of the 3 ways we talked about yesterday to get data, experiment, observation, or do a survey. I'm sure there's more than that, but ask 132 randomly selected people, what is the highest degree they chose? And then I don't have to read for you. There's the results. Okay, so take a minute to write those down if you're a note taker. All right, Mickey Mouse stuff. So the next thing you do is draw. Now, remember what it said up there? The bars could go horizontal or vertical. Which way are the bars going to go in this graph? Horizontally or vertically? They're actually going to go horizontally, right? Because I have the frequency down at the bottom. Frequency is just a general term for how many times does something happen. And it looks like the biggest number is 53. So 10, 20, 30, 40, 50, 60. Looks like I had an idea of going by tens. Very basic Mickey Mouse bar graph, looking at it. And then when we see how many people had none, which was 15, I want to draw a bar that represents schematically or scale-wise close to 15. Looks like it'd extend that a little bit more. And I use highlighters to do the bar graph. Just make it look cool. 22, high school. And so on and so on and so forth. Associates is, I keep picking on those nurses, but I know you can do a 2-year program, right? At JJC, I know they have a popular one there. That's what an associate's degree is, your typical 2-year degree. I don't know what happened there. The old touchscreen feature I can't get rid of on this computer. Love it. I didn't highlight up there, bachelor's, 53. At this point, you should be rolling your eyes, really. This is what we're doing. Yeah, nice little start to the year. Simple. 31 for masters, and then vice versa. If you had this picture, being able to get information off of it as well will be a skill that you'll have to show. Okay, Mickey Mouse. Oh, guess where I'm at? I didn't actually realize it. Where am I at? I'm at my safe spot. So I literally walked around just like 1/4 of the room and then boom, right back, like a magnet. Hey, what percent of people surveyed had a bachelor's degree or higher? We always like to ask these little basic, simple mathematical questions, all right, just to see if you can read the data. And again, this is a Mickey Mouse question. So how many people that represent? Well, I at least have what to start with? Bachelor's or higher. How many people have a bachelor's, everybody? And then what else? What else? Or higher. So what's next? 31. By the way, I have a master's. I should make you call me Master Samuelus. Well, because if you did, I'd feel like a Jedi Knight. Master. No? All right. And then I know if people get a doctorate, which is a PhD, they make you call you doctor. Did anyone have a doctor that they're taught by in school here? Right? And they make you call them doctor. How come I'm not called master? I don't know what that means. All right. And then I don't know why that would happen. So how many total people are there? 132, is that right? This is my favorite part of class. Okay, could someone calculate this for me and get a percent? Holy, I'm going to faint. I'm going to faint. You ruined it, he said. Because my favorite part in class is when I asked the class of 28 students, hey, can someone calculate that for me? And 28 students basically flip me off with their eyeballs and say, no, I'm not going to do that. And then I sit here like a buffoon, okay, please, because I don't want to get my calculator out. But then lo and behold, a knight in shining armor comes out and tells me the answer right away. It's amazing. Let's give him a hand, everybody. See that? Nothing. All right. Okay, so now I put 4 here, but I stuck a 4A because 4 yesterday histogram was there were 2 different types listed, and we'll cover those 2 right now. It's a special bar graph. And I don't know if these are hard and fast rules, but I think this one is that the bars do touch each other as you move from one bin to the next. And what a bin is the grouping of the data and how many happen within that group. And again, the word frequency, how many times something occurs. Okay, so remember, that's why I have that boxed off. I boxed that off one of the last 2 periods saying that again. All right, and then quantitative data is just data that we collected. And, we got this data here that represents test grades again. Okay, so not again. The first time today that we see this data, but this is the same data as yesterday, correct? Remember, we had someone get a 6 on the exam? Yeah, it happens. It does stink. And then we had 4 people get 76s. So don't write both sets of data. It might be too late. But when you see the data, the first thing you should do is write it in order. Those that did number 6 in the homework, wasn't that a pain yesterday? Oh, yeah. If you did it right, and as opposed to copying the answer. To list that, it was a bunch of decimals and a lot of them, and writing them in order was probably hurt your eyes. And so, yeah, but it was a short assignment, so it should have been too bad. All right, so again, write what's in red. That's my writing from yesterday. I just cut and pasted it from yesterday's notes. Just, again, saying that this is what you should do. If they do ask you to do a frequency table, then do it. Okay, but then what it does is makes the graph easy. So we're going to construct a frequency table with a bin size of, this has to be given to you. You don't have to pick this, so do read the question to make sure what size is your bin. A bin size of 10 then therefore means the first grouping of numbers would be 0 to 9. Believe it or not, 0 to 9 is 10 numbers. Then the next bin is 10 to 19. So that's what this chart's going to look like as I zoom down. Hopefully the writing is big enough where I can do both. And I think we should be all right with that. Boom. Okay, so here's what your frequency table will look like. I'll pause to get you to catch up. And that is catch up. You know what I was saying about what you should do for your bins, how they go. It's fine. Okay, so now that you caught up, how many grades happen from 0 to 9? And then this is what we write here. How many? Just 1. That's what frequency means, how many times they happen. How many between 10 and 19? None. 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 How many grades from 40 to 49? 3. And then that's what you put here. That's how many. I'm putting it real close to the line because I'm trying to keep it close to that. 50 to 59, I think you only have 1. No, 60 to 69. Then 1, 2, 3, 4, 5, 6. 6. 80 to 3. Is this exciting? And then 2. All right. So you wouldn't have known this. So a little stretch of the brain, little extra thing. A histogram deals with frequency. Now that I have that table written, comfy there? Oh, those eyes are going down. Remember what I had to do? Let's just sit right here. All right. That's the Mr. Samuel's alarm. Okay. All right. So now here's our, I guess you could choose to go horizontally, vertically with either one. But what we're going to do for the horizontal axis is the frequency. And I'll stop with freak. All right. And then 0, 1. What's the biggest occurrence? 2. What's the biggest occurrence? 3, 6, 4, 5. So that's why we choose to go up to 6, the highest one that occurs. Then across here, we're going to do our bins, which go by They actually go 0 to 9, but we're going to put a 10 there. Kind of was like, first arm, like, wait, should I put 9 there? And no, the idea is this: when I draw the bins, we'll hold off of that thought. And I don't think you need to see me do this live. Okay, so fill out those 0 to 10. And then I'll just choose a different color for aesthetics. Did you just hear me say that word wrong? If I was Donald Trump, I'd be, oh, look at him. He's got mental disorders. He can't say words. Remember when he said United States of America? Anyone see that? Anyone see that? Nobody? The news went wild. He's mentally deranged. He can't speak. Well, that just happened to me, so you can turn me in. All right, here's bin number 1. Right? Okay, from 0 to 10, we had one occurrence. I'm sorry, 0 to 9. Did I say 0 to 9? Sorry, I didn't mean to say that. So why did I go to 10? When the bins are connected, it's implied that it ends at 9, and I know that might be a problem with you. Don't worry about it, okay? Watch the next one when we actually have a connection. 40 to 49, there's 3 of them. If those eyes close, I am screaming. All right, and then from 50 to 59, see, this is the point. There's a jump off, so it's implied that 40 to 49, this box ends at 49, and then this one starts at 50, but we keep them connected. So just, don't overdo it with that. All right, and then nothing from 60, and then 70 to 79 was the big one. Whoa, little slippery there on the screen. Oh, shaky. Steady. All right, and then 80 to 89. And then 90 to 100 was 2 of them. Oof, man. Okay, that's what a histogram. Don't write this down, but this was the point of, you can manipulate the picture depending on your choices. So this is a different set of data, 80, 74, 87, probably a little bit better set of grades there. And then here's a bin size of, well, you tell me, what's that bin size of that picture? Should be simple. What's the bin size? Maybe it's not simple. Okay, 5. That data right here. What's this bin size? Same data. 10. There we go. Now we're moving. What's this bin size? 20. And then the only point of this is just visually looking at this, which is how most people look at stuff, visually. Look at the 3 different pictures. They're the same exact data with different choices on the bin size makes a different looking picture. So depending on what you're trying to convey, those choices make differences about how things can be, actually the negative word from yesterday, manipulated. Okay, so probably for grades, it's better to have a 10 bin size so the book says, this is the good one, ding, 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 ding. Okay, so you don't have to worry about picking bin size. You'll be told what to do. I just wanted to piggyback that thought from yesterday. And then go ahead and write this down, and I'll pause to give you a chance to write this down, and then I'll blab. All right. So a relative frequency histogram. Again, this is, okay. Now the difficulty in this is remembering this term and then what to do. That's your job. Okay, relative frequency histogram is based on the relative frequency of each interval. Same data. Get that data, you put it in order. All right, same data, so we don't have to keep rewriting this over and over again. But here's what a relative frequency, and we're going to do a bin size of 10. That has to be given. So bin size of 10 again. What you have to do for a relative frequency table is get the relative frequency of each bin. And what is relative? Relative to all the others. So that's what relative means. Relative to all the others, what does this bin size, what does this bin represent? So that's found by the number of grades in that particular bin divided by the total grades. Then that would we'll turn that into a decimal. Okay? So as you're writing this down, well, I'll have to fumble doing this, but I need my mouse to do this because I don't want to write these down again. All right, so I'm going to go up. Is anyone still taking the notes there? Sorry. I got to grab this. Yeehaw. Because actually it's the same first step. Same first step is you look at the totals, you look at these numbers, and you find out how each number, how much each. That's great. All right. Thank you, computer. Yet again, thanks for your help. How much each one happens? Same bin size, same numbers, so same results. But now what do I have to do with each one of these numbers? Divide it by? Divide it by? Oh my gosh, what just happened there? That's not you. The computer's turning on me. Yay. Divided by what? Did you guys say it? Divide each one by 16 and get the decimal. Hey, can I have someone help me on that? What's 2 divided by 16? Well, I'll wait. This is going to be the greatest YouTube ever. This is how long it takes 27 high schoolers to do 2 divided by 16 for one teacher. 8? 8? No, 2 divided by 16 is... He did 16 divided by 2. Yeah, but I need the decimal. So I want you to type it on the calculator. This is what teachers go through every day. I don't know. Okay, they're Common Core and out. They're discussing what's 2 divided. Well, if I carry the 1 and then, or you could use a calculator. Calculator. So that would be 0.13. I don't know if you saw that YouTube. That took 7 minutes. No, I don't know. 2 divided by 16. 3 divided by 16. Now we're rolling. Point. Yeah, 27 students. One teacher sitting up here like a buffoon. Safe spot. Rounded. Point 100, so it's like. There we go. 6 divided by 16. 0.3. You just added. Nice, you doubled this. Wow. 0 divided by 16. Go ahead and type that. Oh my gosh. All right, 1 divided by 16. 0.06, is that right? 3 divided by 6. Hey, I don't need you for this one. Thanks, though. 0.19. And then 1 divided by 16. All the other ones are zeros. We already did that one, right? 0.06. Okay, that was fun. All right, and then now what you do is all this is this is the relative frequency that you put up here on this one. So 0, what's the highest one? What's the highest one? So it's 0.3 whatever, so we're going to go to 0.4. You're right. You see my, probably shouldn't have put that so close over here. And then you have the same axis here. I don't feel like turning off the video, so you have to watch me. Oh no, I think I made these too big. I'm going to go off the screen. Oh well. You over the line, Smokey. Anyone know the movie? Oh, never mind. Okay. All right. So look at this. 0.06. So this is somewhere around here. It's bins again, but now it's based off the relative frequency. 0, 0, 0. 40 to 49 is 0.19. 50 to 60 is the nope. 50 to 60 is 0.06. Is about to make that the big one. 60 to 70 is a big 0. 70 to 80 is the 0.38. So close to 40 ballpark. 80 to 90, 0.19. And then stunning stuff, isn't it? 0.13. If you look at this picture compared to the last one, they almost look exactly the same. Proportionally, they actually are. Okay, now, to get this over with, because I kind of took a lot of time, and I'll go back to that if you need it. Here's just some last terms, and then I'm done, and you can do your homework. What do you think a uniform histogram looks like? X and Y axis, or vertical and horizontal axis. If this first bin is this big, and it's a uniform one, what do you think the next bin looks like? Pretty close. Correct. If you said exact, it doesn't necessarily have to be. This would be a uniform histogram, and I don't think I have to draw much more. They're all pretty tight with each other. So that's what that would be. I'm not going to draw two of these. One I think is sufficient. What do you think a symmetric one looks like? Well, if this bin is this big, what would this bin over here be? Same size. And then if this bin is this big, what is this bin? Same size. And then maybe you have one in the middle. And then this could be reversed where the tall one's in the middle and then it looks like a mountain. And that's considered to be symmetric. And then I'll be perfectly honest that I screwed this up a year ago. Not what skewed is, but which way this is skewed. So I think we should write this down. Skewed data obviously is neither of the last two. You know, you got your data way over here, and then it goes like this. And then you could even have, sorry for those bins not being the same size, they should be, but then it looks like this. Now, this is what I screwed up. What is this skewed? Is it skewed left or is it skewed right? This is awesome. I think your teachers of the past taught you the right thing. I, in my mind, said, hey, all that data's on the left, so that looks like it's skewed left. It's actually incorrect. It's skewed right because the idea is the median. What's the median again? Middle. The median is right of most of the data. You know, it's like on the right side of it as far as when we're looking at it. Even though it's in the middle, you know, that's the idea of what's happening there. And then I could draw the other one skewed on the other side. That would be skewed left. Okay, so that was kind of weird when that happened. So we just said that. Median. Middle is what that is. Let's look up at this data again. This is why I had this listed. Why did I have a circle there and then a line through there? Well, how many data points were there? There are how many? How many? It's right there, 16. So what's the middle? The middle is actually the 8th and the 9th. You don't have one number that exists in the middle. So the median is actually the what of 76 and 76, even though you still get the same answer. Average. So the median of this stuff is 76. Oops. Oh, I don't know. Okay, then what's the spread? The spread is what is the lowest number to what is the highest number, and that's it. No math to be done, it's just a list. Hey, the spread of this data starts from 6 and ends at 97. That's the spread. The range, though, is the difference of highest minus lowest. Okay? There's 91 numbers covered from 6 to 97. Not that every number is covered by the data, but that's what that means. Done. Okay, there you go. Have fun.